The evolution of humanoid robotics is accelerating at a pace few could have imagined just a few years ago. What once existed only in science fiction is now stepping into reality, literally. Among the newest and most intriguing developments in this transformation is the Unitree R1 humanoid robot. This machine represents more than a technological experiment. It represents a shift in how robots are designed, how they move, and how they may soon coexist alongside humans. At first glance, the Unitree R1 appears familiar in form, yet profoundly different in capability. Built with a human-like structure, it is designed to operate in environments created for humans. This is not accidental. The humanoid form is one of the most strategic choices in robotics engineering. Our world is built around human dimensions. Stairs, doors, tools, and workspaces all assume a human body. By adopting this structure, the Unitree R1 gains immediate compatibility with the physical world without requiring infrastructure redesign. This alone brings humanoid robots closer to practical deployment than ever before. But the true significance of the Unitree R1 becomes clear the moment it begins to move. Movement is one of the most difficult challenges in robotics. Walking on two legs requires constant balance adjustments, real-time feedback processing, and precise coordination between multiple joints. Every step must be calculated, every shift in weight anticipated. The Unitree R1 demonstrates a level of stability and fluidity that reflects years of engineering refinement. Its movements are not stiff or mechanical. Instead, they appear controlled, responsive, and increasingly natural. This stability is made possible through a sophisticated integration of sensors, actuators, and intelligent control systems. The robot continuously monitors its own position, joint angles, and external forces. It makes micro-adjustments in milliseconds, maintaining equilibrium even during dynamic motion. This level of balance control allows it to function not only in controlled environments, but potentially in real-world settings filled with unpredictability. Agility is another defining characteristic of the Unitree R1. Speed, responsiveness, and coordination are essential if robots are to operate effectively in human environments. The R1 is designed with lightweight structural components and highly efficient actuators that allow rapid, precise motion. This efficiency improves performance while reducing energy consumption, bringing humanoid robots closer to practical, sustained operation. Yet physical movement is only one dimension of the R1's importance. Equally critical is its potential for intelligent integration. Modern humanoid robots are no longer limited to executing fixed, pre-programmed sequences. Instead, they are increasingly capable of adapting their actions based on real-time input. With the integration of artificial intelligence systems, robots like the Unitree R1 can interpret visual information, understand spatial relationships, and respond dynamically to changing conditions. This shift from rigid programming to adaptive intelligence marks one of the most important turning points in robotics history. Machines are no longer limited to repeating predefined actions. They are becoming systems capable of perception, decision-making, and autonomous adjustment. The Unitree R1 is part of this transition. It is not simply a machine that moves. It is a machine designed to learn, adapt, and improve. The implications of this are profound. Humanoid robots have the potential to assist in industries where human labor is difficult, dangerous, or inefficient. They could operate in hazardous environments, perform inspection tasks, assist in logistics, or support research and development. Their humanoid form allows them to use tools, navigate human environments, and perform tasks without requiring specialized robotic infrastructure. This compatibility with human environments is one of the key advantages of humanoid robots. Unlike traditional industrial robots, which require controlled settings and specialized installations, humanoid robots can theoretically operate wherever humans can. This dramatically expands their potential applications. The Unitree R1 also reflects a broader shift in the robotics industry itself. For many years, humanoid robots were primarily experimental, expensive, slow, and limited to laboratory demonstrations. Today, advancements in materials, actuator design, power efficiency, and artificial intelligence are changing that reality. Robots are becoming lighter, faster, smarter, and more capable. This progress is not happening in isolation. It is part of a larger technological convergence. Artificial intelligence is advancing rapidly. Sensor technology is becoming more precise. Computing power is more accessible than ever before. When combined with modern mechanical engineering, these advancements enable robots that would have been impossible just a decade ago. The Unitree R1 exists at the intersection of these technological breakthroughs. It is both a product of this progress and a glimpse into what comes next. It shows how far robotics has come and how much further it can go. Perhaps the most compelling aspect of the Unitree R1 is what it represents for the future of human-machine interaction. For most of history, machines have been tools, passive systems controlled directly by humans. But humanoid robots introduce a new paradigm. These machines are not just tools, they are autonomous systems capable of operating independently within human environments. This does not mean replacing humans. Instead, it introduces the possibility of collaboration. Robots could assist humans, augment human capability, and perform tasks that extend beyond human physical limitations. They could operate continuously, without fatigue, in environments where human safety is at risk. This transformation will not happen overnight. It will occur gradually, step by step, improvement by improvement. Each new generation of humanoid robots will become more capable, more intelligent, and more integrated with artificial intelligence. They will move more naturally, respond more intelligently, and operate more independently. But even now, the significance is undeniable. The Unitree R1 demonstrates that humanoid robots are no longer theoretical. They are real, they are functional, and they are improving rapidly. As you watch the Unitree R1 move, balance, and operate, you are not just watching a machine, you are witnessing a preview of the future. A future where intelligent machines exist not as distant concepts, but as active participants in the physical world. The age of humanoid robots has begun, and the Unitree R1 is one of the clearest signs that this future is already unfolding.